Okay, so question 12, section B. Graphic below shows two spheres in contact with each other. Drawing on the left shows the elevation and the incomplete plan. So we have a big sphere, 40 mil radius, and a small sphere B. We have the large sphere A in plan and the point of contact coming 35 degrees from the centre and down 30 mil. Okay, so we have all the information there to set up the large sphere. So the first thing we're going to do is set up our radius. For people struggling to set up the radius, you can just draw a line, mark it to 40 and set up your compass like that. Okay, or you can take it straight from your ruler, whichever way you find easier. Okay, first thing we're going to do, I'm going to draw our XY line. Okay, I'm going to lightly just put in our centre line. Okay, so it's construction line. Okay, we know it's 40 mil radius, so the centre of the large sphere is 40 mil off the ground. Mark the centre point, and then use that centre point to mark in the sphere, the full radius of the sphere. Okay, so you don't do it heavy yet because there might be some hidden detail. As we can see here, there is hidden detail in the bottom right hand corner, so just make sure you don't go too heavy in the bottom right hand corner for now. Okay, it doesn't give us the distance away from the vertical plane in plan, so we just take 20 mil. If they don't give you a measurement, just measure about 20 mil. Okay, find the center point again. Okay, so there's A in elevation and sphere A in plan. Okay, that's not too difficult, I don't think. I think everyone was okay with that yesterday. So what we're going to do now is we have to finish the elevation and plan putting the sphere in the correct position. Okay, so the first thing we're going to do is we have to find point P here in plan. So from the center point, it's going to be an angle of 35 degrees. So you know that's 35 degrees. And it's going to be 30 mil from the centre line. So we measure down 30 mil from the centre line. And we bring it across to find point P. So we've located point P now in plan. Okay, because it's a sphere as well, we will put in lightly the centre line and plan an elevation. Now. Okay, so the first thing we need to do then is we're going to take P and we're going to find it and we're going to rotate it so we can see the point of contact of the two spheres on the outside circumference. So the first thing we do is find point P and rotate it around onto the centre line. So let's rotate it around onto the centre line. Bring that vertically up. And where it hits the outside circumference, that will be, we'll call that P1. And that can be P1. Okay. So we know if we take the air sphere and just roll it around, turn it around, we'll see point P here. So we know our point of contact of our smaller sphere is going to fit in here somewhere. Okay, and to find the point of contact between two spheres, all we need to do is join the centres. We're going to put a line in there. Through P. So we know that our center line, our center point, and our center point of our sphere, when they join them together, will pass through the point of contact. So what we need to do is find the center point of the small sphere. So the center point has to be located along this line somewhere. So what we're going to do is we're going to use Loci of a point, or the locus of a point. So we're going to measure up 5 mil off the ground line. Lightly bring that in. I'm going to add on 5 mil to the radius of the large sphere. And that will be the center point of a 5 mil sphere, a sphere with a 5 mil radius that would fit in there. So I'm going to put in a 10 mil sphere, or 20 mil, 30 mil radius all the way along. So the center point will travel along a path. They'll all have the center point in common, and when we join it, when it passes through this line, will give us the center point of the only sphere that will fit in underneath here. The only sphere that will be pushed in underneath here that has that point of contact. Okay, so we're going to do 5, 10, 15, and 20. Should be fine. So we have 10, 15, and 20. We'll take them points and we'll roll them around. Okay, so we have 1, 2, 3, 4 points. So the reason for that is, if we got a sphere and we just rolled it along the ground, a 5 mil radius, the center point will travel in that line. Okay, if we got it and rolled it around this big sphere, the center point will travel in a circle along this curve. Same for the 10 mil radius, 15 mil, and 20 mil radius. So we found our center points. Once we have them, we can join them together. Green. And once we join them together, where it cuts, that line here will be the center point of the only sphere that will fit in here to touch point P. So we can see here it's 5, 10, it's roughly about 14, 13 and a half. It's very hard to measure it, so that's why we use the locus of a point. Once we have that done, we can see the distance from here to here will be our radius. We can also see, if we drop down a vertical line from that center point, that will also be our radius. Okay, so we just set up our compass. Make sure it's in the center point and make sure it's not moving. We can draw in the sphere then. And we can see now that that small sphere is sphere B when we have turned the two of them together to line them up along the center line. So I'm going to bring down that center point. And I will put it in plan. Okay, so there's sphere A and that's sphere B when it's rotated. So we've brought it around to the right hand side so we could view it to suit ourselves, to see the point of contact and the two center points. Now we bring it down and we have to just move it back to where it's supposed to be. So all we need to do is continue out this line through point P. Same thing we did here, it's the exact same thing, and we know the center point has to be located along that line somewhere. Okay, so just continue it out. Once we've that done, from the centre of the large sphere A, bring the centre point down and around. And where it cuts this line will be our actual centre point. So that's going to be our centre point of sphere B in the correct position. Okay, so we have the centre point here. We know the radius, so we can set our radius back up again. So we have centre point there, radius. Okay, so just be careful now on the hidden detail. Okay, if it's underneath it, the hidden detail will be on what's behind it. So the small sphere is behind it. That'll be the hidden detail. That will be solid detail. Okay, so just be careful. Then next thing we need to do is locate it back up in elevation. So very simply, the center point's here and the point of contact is here. So they have to be above that, somewhere in elevation. So we can just bring up that line, the center point line. So I'll do it in pink just to show. So if we bring up the center point line here, that we know that center point of that sphere, no matter where it is going to be the same distance off the ground all the time. So once we bring it across, we've located the center point right there in elevation. So make sure you label everything to make it easier and clearer for yourself and for your teacher to mark. So we can see here then the sphere is going to be in front, so we can put that in solid. And we know that the large sphere at the back is going to be hidden detail. So you can put in your hidden detail. Okay. So that's it, apart from the point of contact. So if we have the point of contact here, and we bring it around and around and around, so if we roll it around and around and around, it'll travel as a circle in plan. So if we do the same thing in elevation, if we got, there's the point of contact that we had when we've moved it to the side. That's going to be the point of contact when we've moved it to the side. So that point of contact, if we roll the sphere around and around the larger sphere, that will travel as a circle in plan and a line in elevation. So the point of contact will be the same height off the ground all the time. Same as the center point. So the point of contact comes across, and then we can bring it up. And where they intersect each other then will give you the actual point of contact. So I'll just put it in. So that's your point of contact there. And that's that question fully finished. Most important thing is locating your point of contacts, and you always move the solids around to suit yourself. Okay, so move it around so you can see it. It's the center points, cutting through the point of contact, and then find everything. All the heights stay the same. Move it back to the original position then. Okay, good luck with it.